learn it, the easier it'll be for you. And we use it, at least initially in this unit, just as another unit as in using dimensional analysis. So just to remind you at the top of your notes, dimensional analysis is just a method of converting units. And you use a fractional quantity. So you look at the problem and there's a number in the problem and the unit is given in the problem and you want to take it to a different unit. And so then you use a conversion factor. And again, this just helps you decide whether or not you want to multiply or divide. And if it's beside, that's a multiplication. If it's below, it's a division. So again, the idea is that the given unit will cancel out and we'll get our desired unit. And that's the idea. Now, we're going to talk about a specific unit, the mole, that we use in chemistry. Now, first of all, you're familiar with these kinds of units. You use the word dozen all the time, and 1 dozen is a unit, a number that just means 12. It's a very convenient number for counting eggs or donuts. Okay, instead of saying I need 100 donuts or I need 36 donuts, you say 3 dozen donuts. And if you were to think, oh, I've got 3 dozen donuts, it's really easy. You think that's 36 donuts, 3 times 12. So it's convenient. This is a good size. You can see these 12 donuts. On the other hand, you can see these 12 eggs. It's really good for eggs and donuts because you have large particles. It's not really good for atoms or molecules because atoms and molecules are really, really, really small. And because they're really small, having just a dozen of them is still really, really, really small. So we use a unit of measurement in chemistry called the mole. And a mole is the same amount of pure substance containing the same number of chemical units as there are atoms in exactly 12 grams of carbon. And carbon is just this sort of black material like your pencil lead. So what does that look like? Well, it's not a lot, but it's actually enough so that we can see and measure it on a scale. And that number of atoms that you have in exactly 12 grams of carbon-12 is the number 6.02 times 10 to the 23rd. Just like a dozen equals 12, well, a mole equals 6.02 times 10 to the 23rd. Now I'm going to try to come back here to show you something. Here I am. So I don't have carbon with me, but I want to just show you this is aluminum, okay? So this is a mole. I don't know if you can read that or if it's backwards, sort of backwards on your screen, but this is a mole of aluminum, okay? That means that this has 6.02 times 10 to the 23rd atoms of aluminum in it. I can see that, right? Now, if I had a dozen atoms of aluminum, I wouldn't be able to see it, but I can see this much. It's convenient. Now, every atom's a different size, so I have copper here too. This is actually a mole of copper, okay? And so, again, the idea is in this particular block of copper, I have 6.02 times 10 to the 23rd atoms of copper. So it's just a convenient unit. I can weigh this. I can hold this. I can't hold 1 copper atom. I can't hold a dozen copper atoms, but I can hold a mole of copper atoms. Okay, so let's go back to this. This number, 6.02 times 10 to the 23rd, yeah, you're going to have to memorize it. It's called Avogadro's number in honor of this man, Amedeo Avogadro, who is an interesting fellow, and we'll talk more about him later. But he did a lot of work on sort of making atoms a real thing, and so they named this number 6.02 times 10 to the 23rd after him. Okay, so just to give you an idea of how many atoms this is and how small atoms are, if we were to blow atoms up, for example, to a number of soft drink cans, like if we blew them up to the size of soft drink cans, and we have an Avogadro's number of soft drink cans, 6.02 times 10 to the 23rd soft drink cans, it would cover the surface of the Earth to a depth of over 200 miles, okay? So think about those blocks of metal I showed you. If I took the atoms, the copper atoms in them, or the aluminum atoms, soft drink cans, right? Took the aluminum atoms and blew them up, each one to the size of a soft drink can, it would totally cover the Earth. On the other hand, I could hold that in my hand. If you had an Avogadro's number of unpopped popcorn kernels and then spread them across the United States, the country would be covered in popcorn to a depth of over 9 miles. If you were able to count atoms at the rate of 100 million per second, it would take 2 billion years to count the atoms in 1 mole. Okay, so we always say that Avogadro's number is 6.02 times 10 to the 23rd. This song uses the abbreviation or the rounded number of 6 times 10 to the 23rd. Actually, 6.02 times 10 to the 23rd is 3 significant figures. So when we use that number, we use 3 significant figures. If we use 6 times 10 to the 23rd, we use 2 significant figures. But the song really gives you a good idea about what a mole is. So, let's listen to the song. Enjoy.
Mole is an animal that burrows in the ground, or a spot on your chin that you gotta shave around. But there's another kind of mole of interest to me. That's the kind of mole they use in chemistry. A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now say you had a mole of pennies to distribute around the world. Give to each of the 5 billion grown-ups, boys and girls. There wouldn't be a single soul down and out of luck, 'cause everybody in the world would get $1 trillion. Or say you had a mole of paper and stacked it toward the sky. Paper's awful thin, but that pile would get so high, you'd reach up into outer space. In fact, I think you'd find it'd go up to the moon and back 80 billion times. And a mole is a unit of, have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now suppose a mole of marshmallows fell upon the planet. Over each square inch of land and sea, you think that you could stand it? That layer would be 12 miles high and, of course, block out the sun. We're talking close to 5 million trillion tons. Well, maybe we could save ourselves if we all started eating 1 marshmallow each second. Not 2, because that'd be cheating. With 5 billion people munching, how long do you think it'd take? 40 million years, and that's without a bathroom break. And the mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. But say you had a mole of atoms. Would the pile be immense? Should I say the answer now or leave you in suspense? Well, atoms are so very, very small, you understand. You can hold a mole of atoms in the palm of your hand. So shake a little sugar in the middle of your palm. Now you don't want to spill it, so try and stay calm. You hardly can imagine and barely realize there are more atoms in that sugar than stars up in the sky. And the mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend.
Okay, so now you've seen the song, and you can now start sort of writing here in your notes. Again, it's that 6.02 times 10 to the 23rd. It's based on carbon, but again, you can see that it's a number that you can actually hold the atoms in. So a mole of lithium atoms, lithium's a metal, would simply be, again, 6.02 times 10 to the 23rd atoms. Okay? A mole of H2 molecules would be 6.02 times 10 to the 23rd molecules. It can also be used for counting molecules. We use it for particles, for very small atoms or molecules. If we had a mole of CO2 molecules, that would also be 6.02 times 10 to the 23rd molecules. Hopefully you're writing this in and remembering it. Now, we're going to need to use this as a dimension. You can see on your notes that I've given you the unit. 1 mole equals 6.02 times 10 to the 23rd particles, and the particles can be either atoms or molecules, and you can see the conversion factors as well on your notes. Now, when you need to use this number in your calculator, I think we've gone through this before, but I've put the procedure at the bottom of the first page of notes. So you're going to want to enter it as 6.02, and then find the second button on your calculator and this EE button. It's above the comma, and put in 23. If you have a simpler calculator, just find the EE button. But you want to have something appear on your screen that looks like this, 6.02 E23, and that means 6.02 times 10 to the 23rd. E means times 10, so you don't need to put in times 10. Now, I really feel like this is the best way to do it. If you use this sort of caret thing, it could mess up the logic of your calculator. You want to make sure you put it in parentheses if you resort to that. Okay, so let's do a few dimensional analysis problems. Turn to the second page using Avogadro's number with this conversion factor of 1 mole equals 6.02 times 10 to the 23rd. And again, we're going to just always assume with 6.02 times 10 to the 23rd that that's 3 significant digits. You'll see in some books they go out to 6.022 times 10 to the 23rd, and in some books they go to 6.0, like the song, times 10 to the 23rd. But State of Virginia wants you to remember 1 mole is 6.02 times 10 to the 23rd. So it says, how many atoms of lithium are in 3.5 moles of lithium? So again, idea is that here's our number, here's our given, 3.5 moles. Okay, and what are we trying to get to? We're trying to change that into atoms, right? Here's our atoms. Now we need to put in our conversion factors. So if we want to get rid of moles, put moles on the bottom. And again, these particles here, they can be either atoms or molecules, interchangeable. Okay, so it just depends on what the problem asks for. So you put in 1 mole is 6.02 times 10 to the 23rd, and you see moles cancel. There's our conversion factor. We put this in our calculator. Take a minute, pause, make sure you can do that, and you're going to get 2.11 times 10 to the 24th atoms. Okay, a lot of atoms. Let's do the next one. So this time we're going to go the other way. It says how many moles of lithium are in 3.35 times 10 to the 24th atoms of lithium. So this time our given unit is atoms, and we're trying to get to moles. So you might notice that this way we're multiplying, so what do you think we're going to do this way? You're right, we're going to divide. So this is where putting it correctly in your calculator is really important. If you put it in wrong in your calculator, you're probably going to get 5.56, but you're going to get this enormous times e to like the 47th, 48th or something. So just be really careful if you do that. Call me over, I'll help you learn how to put it in your calculator. So here we go, 3.35 times 10 to the 24th, here's our conversion factor, right? Comes directly from there. This time it's in the bottom, so we can cancel and go to moles. All right, so let's try a couple on your own. You've got 5.61 moles of iron. You may want to pause the video and see if you can work out the answer. Here's some possible choices. And pause the video. I'm not going to stop, though. You should have gotten this answer. Did you? Okay, make sure you're writing out your T-chart on the second page of your notes. Here's another problem. This time we're going atoms to moles. Okay, so again, I'm just going to warn you, if you get a huge number like that, it's going to be wrong. Okay, that's putting in the calculator wrong. So which one did you get? You should have gotten 15.5 moles if you did this correctly. All right, so got one last riddle, and then we're done essentially with the video. What do you get when you cut an avocado into 6 times 10 to the 23rd pieces? This is Chemistry Cat. I love Chemistry Cat. So what do you get when you cut an avocado into 6 times 10 to the 23 pieces? You know what you get? You get guacamole. Do you get it? Avocados make up guacamole, and there's the mole, ha ha, ha ha, ha ha, and that's a mole, ha ha. So now what I want you to do, and I'm going to come back here just a second. Now what I want you to do is, there is an example problem on the third page here. Take a look at it, and then there's some problems for you to do for practice. And they have answers right beside them, okay, right beside them. But I want you to do the T-chart down here and be sure you know how to do the answers. You can't just rewrite the answer. Show me how you got the answer. Okay, so that's your video.